We're going to continue to move forward here. In our next section we're going to talk about is going to be inverse functions. And so when we're talking about inverse, which should be a word you're familiar with from back in the beginning of Algebra 1, when you talked about inverse operations, we talked about things like the inverse of adding 3 being subtracting 3. So inverse refers to an opposite, or doing something backwards. So when you look at the part in red here, the description that describes what an inverse function is, it's the opposite function. That means if your original function has the point x comma y on it, its inverse function will have the point y comma x on it. Every point will be flipped around. If you look at the tables to the right, there's f of x and f inverse of x. We use that -1 power to signify an inverse. So when you look at the values for our first table, the point -410 is on the function f of x. Well, if that means that the second table represents the inverse of f of x, f inverse of x has the exact opposite point on it, the point 10 -4. The point -29 is on the original, so the point 9 -2 is on the inverse function. So that's what we're talking about when we're defining what an inverse function is. Here is a list of steps to follow when you're finding inverse functions. To start with, we're going to change our function notation back to our traditional notation where we use y instead of f of x. So we're going to change f of x to y for our first step. Then you're going to switch x and y in the equation because that's what we said it means to be an inverse. Each point is flipped your x and y values. Then we're going to solve that equation for y, and then we're going to make sure that that new value, new thing we have created is a function. That inverse, check to see if it is a function. And so therefore, we should add a step here. A fifth step would be write as f inverse of x. Instead of using y, our final inverse answer should be in the form f inverse of x equals. So let's look at what this actually looks like in practice. Usually these things make more sense once you've seen an actual practice problem. So if we're given something like this and asked to find the inverse of f of x equals x plus 3 divided by 2. To begin with, we're going to write the problem with a y in it instead of f of x because it's easier to solve with y in there. Now, this is our original function. In order to make it into an inverse, we do a translation. We flip our x and our y. Now, in order to put it back into function notation, we need to have y equals. So we go through some solving steps. I want to get rid of divided by 2, so I'm going to times 2. To get y equals, we'd have to minus 3. So that would be the inverse function. But in order to write our answer in function notation, we would say the inverse function of x is 2x minus 3. That becomes the final answer. That's our inverse function. So the concept of an inverse is not complex. All we're doing is trading out our x points for our y points. So in an equation, what that looks like is simply flip x and y and solve for y. Once you get y by itself, we write it as a function. F inverse of x equals 2x minus 3, and this is a function. We'll get into some more complex examples in your homework where you'll be challenged with your solving abilities a little bit, but this is the basic concept of what you're doing when you're finding an inverse. So let's take a quick moment and look at a function that does not have an inverse. And so we start with the function f of x equals x squared plus 12. We're going to change that to y equals to begin with. and that is a function. It's a quadratic function. When we go to find the inverse of that, you subtract 12 from both. I'm sorry, I missed a step there. We need to first flip our x and our y. X equals y squared plus 12 minus 12. And in order to get rid of that square, we'll use the square root method. And we'll come up here, which says then the square root of x minus 12 equals y. Hopefully a couple of you have caught on right now that we have not given a complete solution. Because whenever we use the square root method, we said we create two solutions, plus or minus. So now we have a problem. Our inverse equation is y equals plus or minus radical x minus 12. And the problem is that's not a function. Because remember, a function means for every input there is only one distinct output. However, in this case, we've created two, because of that plus or minus, we've created two outputs for each x you put in. If you put in an x and calculate it out, you will get both a positive and a negative solution. So that means this original function has no inverse. Alright, so that's why we said that fourth step in our problem solving, our inverse solving process, is to check and see, is your new solution an inverse? So recognize that x squared situation is going to create no inverse, because when you take a square root, you'll get the plus or minus situation. Our last part today is going to be what's called verifying inverses. We can find inverses by switching x and y. There is another rule that allows us to verify if two functions are inverses of one another without having to do quite as much work. It says if two functions, f of x and g of x, are inverses of one another, then f of g of x will equal x, and g of f of x will equal x. In other words, when you plug one equation into the other, everything should cancel out except for an x. Let's see if these two functions, f of x and g of x, are inverses of one another. To begin with, we'll find f of g of x. So we're going to plug g into f. 1 minus the cubed root of 1 minus x cubed. Based on what we've done previously, hopefully we recognize the cubed root and the cube cancel each other out, making it 1 minus x. And we distribute our negative 1, making it 1 minus 1 plus x. 1 minus 1 is 0, plus x is x. So f of g of x worked out to be just x. That says these could be inverses of each other. To verify for sure that they are, we do g of f of x. G of f of x says plug f into g. So the cubed root of 1 minus x cubed. The cube there was placed in the wrong place, so it should be 1 minus x cubed on the inside. When we combine our like terms, it's the cubed root of x cubed, which is x. So therefore, both equations simplified down to just x. That tells us those are inverses of one another. So, if you're asked to find the inverse to an equation, you flip x and y, solve for y. If you're asked to verify that two functions are inverses of one another, you simply plug g into f and f into g, and both of those problems will simplify down to just x.